Welcome to The Explainer. Today, we're going deep. I mean, really deep underground. We're going to break down the amazing technology that pulls data from thousands of feet below the surface. And at the heart of it all, these critical little sensors called transducers.
Okay, let's kick things off with a simple but super important rule in pretty much all engineering. Rubbish in, rubbish out. It's that simple. If the information you start with is junk, guess what? Your results are going to be junk too. No way around it.
And, in the world of well testing, that principle isn't just a guideline, it's everything. I mean, we're talking about decisions worth millions, sometimes even billions of dollars. So, yeah, you can see why getting that data right from the get-go is, well, it's absolutely non-negotiable.
We've definitely come a long way from the old days of these, clunky mechanical gauges. Today, it's all about sophisticated electronic systems, with computers grabbing data automatically. But here's the thing. No matter how fancy the tech gets, the basic goal is exactly the same. We still need accurate, valid data so we can make the right calls.
So the big question is, how do we make sure we're getting that high-quality data? Well, we rely on a little device called a pressure transducer. You can really think of it as our eyes and ears way down there in the well. And just like any tool you rely on, you have to know exactly how it's going to perform, especially under some pretty intense conditions.
When you're evaluating one of these transducers, it all comes down to its performance parameters. You've got two main types, static and dynamic. For now, let's just focus on the static ones. These basically tell us how the sensor acts when things are stable and not changing, which is really the foundation for everything else. All right, first up on the report card is accuracy. And this is the big one. It's not just about getting close to the right number. Think of it more like the final grade. It tells you how close a measurement is to the actual true value, once you factor in all the little errors that can sneak in, things like temperature changes or even the sensor's own little quirks.
Next, we've got resolution, and this is all about the fine details. It's like trying to measure a single grain of sand with a ruler meant for measuring a room. It's just not going to happen. Resolution tells us what's the tiniest, smallest possible change in pressure that the sensor can actually detect and tell us about. And in this game, those tiny changes can be a huge deal, so you want that resolution to be as high as possible.
And last but not least, we have stability, or its annoying cousin, drift. See, a sensor can be perfectly accurate when you first turn it on, but what about after hours or days or even months down in a hot well? Is it going to stay accurate? That's what stability is all about. It's a measure of whether the readings are going to stay consistent and trustworthy for the whole test.
Okay, so now that we've got a handle on the report card, accuracy, resolution, and stability, let's check out the three main types of transducers you'll actually see out in the field. They each work a little differently, and they all have their own pros and cons.
This chart is great because it really lays out the trade-offs, right? On one end, you've got the strain gauge. It's tough, it's cheap. Then there's the capacitance sensor, which is pretty stable. And then you have the quartz crystal, which is just in a whole different league when it comes to accuracy. The key thing to see here is that there's no single best sensor for everything. It's always a balancing act.
Yeah, this really shows the two extremes perfectly. You've got the strain gauge, which is like your reliable, everyday workhorse, and then you have the quartz crystal. That's your high-tech precision instrument. Think about it. If you're working on a deep-sea well where having to redo a test costs millions of dollars, well, suddenly the higher price tag on that quartz sensor seems like a pretty smart investment for getting it right the first time. So let's zoom in on that high-end performer, the quartz crystal. What is it that makes this thing so incredibly accurate and stable? It's pretty amazing, and the science behind it is actually really cool and elegant. Okay, so here's the magic. Inside the sensor, there's this tiny quartz crystal that's vibrating or humming at a super precise frequency. Now, when the pressure from the well starts to squeeze it, that frequency changes. And it's so sensitive that even the tiniest, almost unnoticeable change in pressure creates a change in vibration that we can measure. And that's what gives it that crazy high resolution we were talking about. And the technology keeps getting better. A really huge step forward is something called the crystal quartz gauge, or CQG technology. Now, this is clever. Instead of having one sensor for pressure and another one for temperature, this design combines them into a single unified piece of quartz. Why is that a big deal? Well, it gets rid of a ton of old problems, like errors you'd get when the temperature was swinging around, or issues from having two separate parts that age at different rates. So, okay,
We have all these different technologies, right? From the toughest nails strain gauge all the way up to the super precise CGQGM. So how does an engineer on the ground actually decide which one to use for a particular job? It's a huge decision, one that can affect the whole project.
And really, this is the main takeaway. It's not about finding the one sensor that's the best overall. There's no such thing. It's all about finding the one that has the right trade-offs for that specific mission. Does it need to be super accurate, super stable, cost-effective? Understanding those performance parameters we covered, that's what lets an engineer pick the absolute right tool for the job.
So that leaves us with one final thing to think about. As we push into tougher and tougher environments to find energy, our need for better, more reliable data is only going to grow. So what's next? What's the next generation of sensors going to look like? What technology comes after quartz? That's the question that engineers are tackling right now, pushing the limits of what we can do deep, deep beneath our feet. Thanks for joining me on The Explainer.